Hello team, welcome back. Welcome to Terraform training. And today we will see built-in functions in Terraform. So we have already discussed about the conditional statements in Terraform. Today we will see what built-in functions are available in the Terraform configuration language so that we can get the leverage from these functions. So let's start with. In the Terraform configuration language or HCL, user can use the built-in functions because Terraform provides a bunch of built-in functions which are quite helpful in the configuration language. Functions are called with the syntax function name, then you need to define the number of argument which is recommended in the function, right? Some function accept single argument, some function accept multiple argument, some function accept only the string kind of argument, some accept numeric kind of argument, and some accept the list or map kind of argument as well. So we have already seen few functions in our earlier lectures, in our earlier examples or labs. For example, we can understand the file function. If you remember, we are using the file function since long, and we were using the file function to define the public key to the Amazon, right? We also have used the lookup functions in the maps to identify the AMI corresponding to the US East 2, US East 1, US West 2, or US West 1. We will discuss some more functions which are commonly used in the Terraform configuration language so that whenever you are going to plan or create your configuration file, you can use these functions. The first function I would like to discuss about the base64 encoding. Sometime we need to encrypt the data, we need to encode the string, so we can use the base64 encoding and we can supply a string to the base64 encode function so that whatever the string you will supply to this function will return the 64-bit encryption or 64-bit encoding of that particular string. In the similar, to decrypt the string, we have the base64 decode. If you want to decode the base64 encrypted string, then you can use the function base64 decode and it will return you the actual string after the decryption of the supplied value. The next function we have the chomp. It will accept the string and it will remove all trailing new lines from the given string. If the string which we are going to supply to this function that have some trailing new lines, then it will remove all the trailing new lines from the given string. Then this is an important function which is called the chunk list. Chunk list will accept the two parameter. First it will accept the list and second it will accept the size. So in the first argument we can define the list of the values that could be the subnet, that could be the IP range, that could be anything, right? And in the second one we can supply the size that will return the list items chunked by the size. It means if you are defining a list, right, and you are defining a size 1, then this function will return the number of list and each list will have the one value. For example, we can understand this in this way. Suppose we have a chunk list AWS subnet, then we are providing some subnet ID and then we are providing the size is 1. Then the output will be the list, right, and that list will contain a list itself. So over here you can see if the subnet are 3, then this will return id 1. This is a one list, id 2 this is the another list, and id 3 this is in the another list. But if we providing like this chunk list variable of the string and we are defining the size 2, then the output will be chunked and each inner list will have the two elements, right? So if there are 5 elements, then the first list will have the id1 id2, the second one will have id3 and id4, and the last one will have the id5. So chunk list will chunk the number of list as per the given elements. The next function is the callsec. Callsec will accept the n number of argument and that will return the first non-empty value from the given argument, and at least two argument must be provided. So suppose if we are providing the multiple script and the starting of the argument are basically the null values, then callsec will find out the first non-empty string and it will return that particular string as a value. Then we have the callsec list. Callsec list will do the same thing. It will accept the n number of argument and it will return the first non-empty list. If there is empty list in the callsec list function, then this will return the first non-empty list as a value. The next function which is commonly used is the compact. Compact will supply the list as a argument and it will remove empty string element from the list. So suppose the argument which you are supplying to the compact, that is a list, and if this list have some empty values, then compact function will remove all the empty values from that particular list and return the list which don't have any empty value. So this is a useful function which you will use in your configuration files multiple times whenever you will work on the production systems. To concatenate the number of list, we have the another inbuilt function or built-in function in the Terraform, concat. Concat will accept the n number of list as a argument, and it will club or it will combine all the list, and it will return a single list which will be the union of all supplied arguments. If you want to identify that a particular list can contain an element, then you can use the contains. You can provide the list and you can provide the element. If that list contain that element, then this function will return true. Otherwise, this function will return false. The next function or inbuilt function is the element that will accept the two argument. First is the list and second is the index. If you want to identify the element present at a particular index, you can use the element function. This function will return the element which is present at a given index. Then we have the file. We have already learned about the file and we are using the file to supply the public key. This will read the content of a file into a string. If you want to identify a length of a list, then you can use the length function in the Terraform. Then we have the next function lookup. This will accept the map value, key value, and the default value. We are also using the map in our earlier provider.tf file, where we was using the map to identify the AMI corresponding to the. So if you remember, we have created the map. Let me show you an example. If you will open up any old configuration inside the provider, inside the create instance.tf, you can see for the AMI we were using the lookup. The first was the map, variable map, and second was the key. If you will go to the variables.tf, then you can see over here we have the AMI map. The type is map. This is the key and this is the value. This is the key and this is the value. And whenever we will call the lookup, we will call the map and the value. And over here we need to provide the map key. If this key will present in this given map, right, then this will return the value of that particular key. Otherwise, in the lookup you can define the default, so that if the key is not present in the map, then the default value will be returned. The next function is the timestamp. Timestamp function will return the UTC timestamp string in RFC 339. Right, that RFC 339 is the timestamp format on which you can Google around it. Timestamp function will return the timestamp. The timestamp function can be helpful in the tags, that can also be helpful in the resource naming convention. Then we have the another function which is also an important function, trim space. It will accept the string as the argument and it will return the copy of the string with trimming all the leading and trailing white space. And the next function is the UUID. UUID will return the random UUID string, and this string will change with every invocation of the function. It means each time whenever you will call this function, it will return the unique UUID string. So these are some common and important functions which are present inside the Terraform configuration. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see how we can put up the loops in Terraform configuration language. We will see what are the loops we are getting in Terraform configuration language and how we can use these loops in Terraform. So let's start with Terraform configuration language, or Terraform offers several different looping constructs. There are few we are listing over here. The first one is the count. Count is also a loop construct in Terraform that will loop over the resources in Terraform. After the count, the second loop, we have the for loop. For loop will iterate over the list and the maps in Terraform. I believe you must have the knowledge of the for loop. The next loop construct, we have the for each. For each loop will basically loop or iterate over the resources and the inline blocks within the resources. So these are the three looping construct we are getting in the Terraform: count, for, and for each. Count and for each will basically loop over the resources in the Terraform, but for loop will iterate over the list and the maps. So we will discuss about the count, for, and for each separately. First, let's discuss about the count parameter. Count is used to loop over the resources in the Terraform. When I'm saying the resources means the resource syntax which is present in the Terraform. Like for provider, you have the provider. For VPC, we have the VPC. For security group, we have the AWS underscore security group. So these are the resources in the Terraform. With the help of the count, you can put a loop over the resources, and this can be used to create the multiple resources in Terraform. When I'm saying to create the multiple resources, it means create a multiple copy of a single resource defined in the Terraform. Let's take an example of creating an IAM user with the help of the Terraform. If you are going to create an IAM user with the help of the Terraform, you need to define some syntax like that. You will define the provider, you will define the reason, then you will define a resource AWS underscore IAM underscore user. Then you need to define the variable which will contain this resource, and you will define the name of your IAM user. This is the basic syntax to create the basic IAM user. Now I want to create multiple IAM users. Suppose I want to create 5 IAM users using the single configuration command. In that case, do I need to copy this resource IAM user 5 times? Or is there any another way to create the 5 IAM users using the single command? Yes, there is a way. You need to define a syntax like that. For I equals to 0, I less than 5, I plus plus, resource AWS IAM user, user example, my name is my user. This syntax you must be familiar. If you are using the programming languages, you have the basic syntax knowledge of the programming languages, then this is the for loop syntax. But question is, will it work with the Terraform? And the answer is no. It won't work with the Terraform configuration language. And why that syntax won't work with the Terraform? Because Terraform does not have loops on the resources like programming languages. Count can be used to create the multiple copies of resources in the Terraform, and the syntax will be look like this. You will define the provider AWS, region US East 2. Then you will define your resource AWS IAM user, the variable which will contain the resource. Then you will define the count. So over here I'm defining 3. It means I need to create the 3 IAM user. This syntax will create the 3 IAM user, and in the name you are defining the name, my name dot, then the value of count dot index. Using this way, this will create the 3 users, 3 AWS IAM users, my user 1, my user 2, and my user 3. Please make sure whenever we are using the count, right, then we will keep the unique name. So over here you can see I'm taking the name like my user dot, then the index of the count, right? If you will define a simple variable in the name, then it will create all the IAM users with the same name. So that may be the problem with some resources. That is not a good way to work on the production. So we need to make sure that whenever we are using the count, we will keep the index on the name field, or we will put some another way to keep the resource name unique like UUID or the timestamp. Now after the count, let's discuss about the for. What are the for parameters and how we can define the for loop in Terraform? So for is used to iterate over the list and maps. For loop is used to generate the single value. Whenever we are going to execute the for loop, the output of the for loop will be a single value, and that will be a list. The syntax for the for loop will be like this. So first we will define the list. Inside the list we will define the for, right? After the for, we will define the item on which item this loop is going to execute. Then we will define the in syntax, and after the in, we will define the list, right? So this for loop will execute for the items which are present in this list. Then we will define the double quotes. Then after this, we will put a colon and we will put a output value, right? It means this for loop will iterate over the items which are present in this list and produce the output in this output variable, and this is a single value. You can see this output is a single value, right? And the output of this complete for loop will be a list. Now let's discuss about some sample of the for loop. So here is the sample of the for loop. You can see over here we have the variable called names. Then we have the description. That description is an optional. The description is a list of the names. Then we have the type. This type is a list type. And we have some default value for my variable called name. And in the default value, we have the names like Mark, Trinity, and John. Over here we have the outputs. And inside the output, suppose what I want, all the default values which I'm supplying in this name variable, they will be converted in the uppercase. So here you can see I'm defining a loop for. You can see I'm defining the for loop. Then we are defining a name. This is the item in where's dot names. It means this is the variable, and we are putting a complete output into a another single value upper name. It means it will convert the all items into the uppercase. So this is the example of the for loop. With the help of the for loop, you can iterate over the CIDR block range, you can iterate over the security groups, you can iterate over the IAM users, you can iterate over the tags, right? There could be the multiple use of the for loop. Now let's see how we can use the for loop with the map. So when we are going to use the for loop with the map, so over here we have the for, then the key of the map. After that, we need to define the value of the map, and then we need to define that this key value is basically present in the map or not. And once it will execute, it will produce the complete output into a single value which is called output. And here is the sample code of the for each. You can see we have the variable program that has the description is a map, then we have the type map string, default, then inside the default you can see these all things, right? This complete syntax is a map. You can say default have the curly braces, then here we are closing the curly braces. This is the key, the mark is the key, and the software engineer is the value. So we have a map like Mark is a software engineer, Trinity AI program, and John is a machine operator. Then inside the output of the roles, we are iterating over this map. We are saying for name comma roles in the where dot program. This is my variable. Put dollar name is a role. It means the output of this program will be like Mark is the software, Trinity is AI program, and John is machine operator. Now this is the last loop in Terraform, which is for each. For each is used to create multiple copies of a resources or inline blocks. The count was only applicable to create the multiple copies of the resources. But what if we want to work with the inline blocks as well? When I'm saying the inline block, you can take an example. Inside the security group, you will define the multiple egress or multiple ingress rules. So these egress and the ingress is basically the part of the resource, but that is a block itself. A single egress or a single ingress is a part of a security group resource. So with the help of the for each, you can create multiple egress and multiple ingress rule within a single resource, that is a security group. Syntax of the for each loop will look like this. We have the resource provider, then we have the name of that provider, then for each. Over here, after the for each, we need to define the collection. That could be the map or that could be the list. Then we need to define the configuration. The simplest example is this. We have a variable user names, then the description create IAM user with these names, right? Then we have the type of this variable, which is a string. Then we have the default value like Mark, Trinity, and John. Over here we have the resource AWS IAM user example. We are putting a for each on the variable username. See, we are putting a for each on this particular variable username, and then we are putting name equals to each dot value. This is the simplest example of the for each. So this is the way how you can work on the loops in Terraform. In the coming lecture, we will see a lab how we can work with the for and for each. We have already seen the count. You can simply create an EC2 instance. This is an exercise for you. You need to create the EC2 instance, multiple EC2 instance with the help of the count variable. So thank you team. See you in the next lecture. Hello team. Welcome back. Welcome to Terraform training. And today let's discuss about the ideal or the recommended project structure for the Terraform project. So let's start with. So till date in this training, we have seen a lot of labs in this Terraform training. And in each lab, we have created a new directory and we created the configuration file in that directory. We have discussed about the modules as well. And we have already seen that how we can use the output variable from the modules as an input in the other configuration files. So when you start the Terraform on the production, you need a good project structure. Why we need a good project structure? Because we can remove the redundancy and we can avoid the failures. So we must need a reliable project structure so that in a single go we can configure the correct infrastructure for my production servers. Terraform code modules are necessary in the production project. So a very necessary and the must part in Terraform production project is the code modules. You must need to create the custom code modules which can be reusable with the different project. If you have a complete infrastructure as a module, then you can use the same module for the development, staging environment and the production environment. So that if you have any error in your modules, if you have any error in your configuration file, that can be captured in the earlier stage. That can be captured either in the development or the staging environment, that will not directly appear on the production environments. Ideally, there should be the separate environment for development, staging and production. If you are working a big project, then what I recommend, you need to create the separate AWS or public cloud account for the different project. You need to create one account for the development, another account for the staging and another account for the production. Although you can create a parent account which can be configured billing of all three accounts, but the recommended practice in the cloud that you must need to create the different accounts for the different environment. Your engineering, your development team should use one account. All the deployment will go in that particular account. Your staging or the regression or performance or any other pre-production environment will directly go to the staging project or staging account. And your production account will only have your production deployment. Your production account will not mix your development and the regression or staging or pre-production, because when we are creating the separate account for each environment, that will provide a lot of other flexibility as well. That will provide a lot of benefit in case of you can keep the separate VPC for the production and separate VPC for the development. You can keep the separate machine type, separate firewall rules, separate configuration, set for security domains, set for security groups. Everything will be separate, right? None of the resource which is running or exist in your cloud environment that will be shared between the development and the production. So the complete development stack will execute in a single account and complete production stack will execute in another account. As I told you, we have discussed multiple case. The separate project structure will help us to avoid the errors in the production directly. For better isolation, it's best to create the separate cloud accounts for each environment. Split the Terraform multiple services and the directories. Organization in these days are not working on the waterfall model. Almost 95 or 96% organization already adopted the Agile. So the complete development and the complete release cycle are basically modularized, right? Right now, in current days, we have the small release, and in Agile, the development team are basically releasing the big features in small chunks, right? So what we can do, we can divide the Terraform configuration file into the services. So each module or each service which is the part of your enterprise service can have the separate directory, which will help us to create the resources in isolation. Also, that will minimize the infrastructure deployment time. So these are a few things we need to consider whenever we are developing the project structure for the production. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last lecture, we have discussed about the ideal structure for the production project. Today, we will see a lab on this. We will create few resources and we will create these resources in the development and production. We will create few resources in AWS with the help of the Terraform, and we will create these resources in the separate project. Same resources will be created in development and same resources will be created in the production environment. I don't have the two AWS accounts, so that I'm going to use the single AWS account, and I will create both production and development resources in the same account. So in this lab, we are going to use the handy VPC module from the registry.terraform.io, and we will create the VPC and instances which will use our custom VPC. Now VPC and the custom instances will be created in the both environment, development and production with the help of the development and production specific files. So let's go to the code editor and create the project configuration files. So here I'm on my code editor, and inside the Terraform directory, I will create a new folder called Terraform project structure. The main directory is being created. Inside the Terraform project structure, I will create the three directories. First is the module, second is development for the development project, and third is the production for the production project. So I will create a new folder called modules. Now I will create another directory called development, and I will create one more directory called production. So we have the three directories: modules, development, and the production. In the module, we will create the modules which will be used in the development and the production. So first I will create another directory for the VPC, and in the VPC we will create a new file called vpc.tf. So you can see the vpc.tf present inside the Terraform project structure modules VPC, then the vpc.tf. Over here in this file, we will define the custom VPC for my project. So first we will define the VPC over here. And as I told you that we are going to use the handy VPC, so we will use the module, and we will call the module name like level up hyphen VPC. And in the source, we will get the source from the Terraform IO registry or registry.terraform.io. So over here you can see I have defined the complete module. First I'm defining the source, and inside the source I'm defining the source of the module is Terraform-AWS module VPC AWS. This source you will get from the registry.terraform.io. Then we are defining the name of my VPC. Then this is the prefix. Then the name will be VPC hyphen, then the name of your environment. The CIDR block we are defining 10.0.0.0, CIDR block 16. In the availability zone, we are defining availability zone like variable AWS region A, variable AWS region B, variable AWS region C. It means if we are defining a variable and the AWS region is US East 2, then the availability zone will be US East 2A, US East 2B, and US East 2C. We are defining the private subnets and the public subnets. The private subnet is from 10.0.1.0.24, 10.0.2.0.24, and 10.0.3.0.24. In the same way, the public subnet is 101, 102, and 103. Net gateway, VPN gateway, both are false. Inside the tag is Terraform true, and we are putting the variable var.environment. After the VPC, we need to define some output values over here. And the output which we define inside the module, they can be used as an input in the configuration file which is going to use that particular module, because in the output we have the output values of our resources which we can use further where we are using the modules. So we will define few output values over here. Then the output variables are defined, and I'm defining three output. First is the my VPC ID. This is the output my VPC ID. The description is VPC ID, and the value of this output will be module. Then the name of your VPC, level up VPC. You can say this is the name of my VPC, right? And then we are defining the output value itself, my VPC ID. In the same way, we are taking the module level up hyphen VPC private subnets and level up hyphen VPC public subnets. The private subnet and the public subnet will return the list, but this will return the single string value. Why the private subnet and public subnet will return the list? Because these are the list items over here. See, now we have defined the vpc.tf. Over here we are using two variables. First is the environment and second is the AWS region. So we need to define one more Terraform file called vpc called variable.tf. So we'll define variable.tf, and in the variable.tf we will define both of these variables, environment and the AWS region. Over here you can see I am defining both of the variables AWS region. The default value is US East 2 and the environment default is blank. Now inside the module we have created the VPC, and inside the VPC we have defined the VPC. Now let's create one more directory inside the modules, and let's call it instances, right? And in the instances we will define the Terraform configuration file which is required to create the instance which will use this custom VPC. So here I will create one more file called main.tf or called createinstance.tf. Here we will define the create instance definition and the security group definition. So first let's define the create instance definition. And here inside the create instance.tf we will define few things like the public access key, the security group, and the create instance.tf. So first let's define the public key. So over here we are defining the public key AWS key pair level up underscore key. The name of the key will be same. This is reading the file from a variable public key path. Later on we will define this variable inside the variable.tf. Now let's define the security group. Then over here you can see we are defining the security group named allow SSH. In the VPC ID we are taking a variable VPC underscore ID. The name we are taking allow SSH hyphen then the variable environment. The description we are mentioning the description of this particular resource group. Then we are defining the egress and ingress, and we don't need to explain the egress and ingress again and again, and then we are defining the tags. After this, let's define the instance group. Then over here we are defining the create instance AWS instance. The name of your variable will be my hyphen instance. AMI, we are taking the AMI from the variable AMIs on the basis of the AWS region. The lookup function, this is the interpolation function we have already discussed. So for this lookup function, this is the map and this is going to be the key, and it will choose the value against this key, and it will choose the value against, and it will choose the value which is present in the variable AMI's map against this particular key. Instance type, this again going to be picked from a variable instance underscore type. The subnet ID we are taking from a variable public subnets. So variable public subnet which I have defined inside the vpc.tf. See, over here we have defined the public subnets. So this create instance.tf is taking the value from that particular variable, and as this is a list and we are using a element function to get the 0th index value. The security group IDs, AWS security group allow ssh.id. This is the security group which we just declared over here, allow ssh. Then the key, AWS key pair level up key name which we have defined over here. Then we are taking two tags, name instance hyphen environment variable name, then the environment which is again environment variable. So again we need to create the variable.tf over here where we need to define few variables. This variable.tf will contain the variables for the create instance.tf. The first variable we need is the key, right? So we need the public path of the key, and we are choosing the public path key variable, and we are defining the variable public underscore key path and the default value of the level up dot pub which is present inside the .ssh directory. If you remember few labs ago we have created this, right? We have created the level up dot pub inside the .ssh. Next we need to get the VPC ID. So let's create the variable VPC underscore ID. The type is a string and default value is null. We need to create the environment. So we create the environment. So we create the environment with the default value null. And next we need to create the AMI's map and AWS region. So let's create these. So we are creating AWS region, default value is US East 2, and creating the AMI's map which have the AMI for the US East 1, US East 2, US West 2, US West 1. Right? Now let's check if we need to create some other variable as well. Now we need to create the instance type and the public subnets. So we are creating the instance type, and this is the default value t2.micro. Similarly, we will create the public subnets. So we are defining the public subnet, the type is list. So these are the variables which we have defined for the create instance.tf. Now let's minimize these files and I will go to the development. Inside the development, I will create the main.tf for the development environment. Purpose of this file to create the resources for the development environment. So over here, first we need to create the VPC. So we will define a VPC like module, define it dev-vpc, which is the module name, and we need to define the source. What is the source in my case? In my case, the source is my local directory, which is /modules/vpc, right? This is the directory. Inside the modules, we have the VPC. Then if you go to the VPC, what are the variables we need? We need the AWS region and the environment. So we will go with the environment, declare it here, and define the environment value. If you want, you can directly define it from the another variable like env. And what was the another variable? Which was the AWS region. And suppose we also reading it from the variable AWS. So these are the only two variables which was required in the module VPC. Now let's create another module called dev instances. And this module will create the EC2 instances. So we will define source, and from where it will read the source. It will read the source from the modules/instances. Please make sure we are providing the correct spelling of the directory over here, which we have defined over here. So we have the modules and the instances. Now in the instances, what are the variables do we have? We have few variables like VPC ID, environment, AWS region, instance type, and the public subnet. So we will go to the main.tf and copy two lines from here because these two variables are common. Then we will define the VPC underscore ID. How we need to read this VPC ID? This VPC ID will be the ID of this particular VPC which we are creating in this module dev-vpc. So we will define a value like module dot define the module name dev-vpc dot, let's go to the module, and here what was the variable was my VPC ID. So I will copy it and provide here. So this is the way how we can read the output of the module in the input of the files which are basically using the module. After the VPC, what we need to define? The AWS region, we will define it externally. Environment, we have already taken it externally. VPC ID we have defined. Public key path we don't need to define. AMIs we don't need to define. Instance type default is T2 micro, so we don't need to define it. We need to define the public subnets. So go to the main.tf, define the public subnets. Let's provide proper indentation over here as well, and this will again come from the modules dot dev-vpc. What was the public subnet in the VPC? The public subnet was the public underscore subnet. So I will copy this and provide it over here. Right, let's minimize the modules and create one more file over here called variable.tf. Before the module, one more thing, let's define the provider as well. So we'll define the provider AWS, right, and we are taking the reason from the variable. Let's save this and define one more file in the development called variable.tf, which will keep the specific variable to this main.tf file. So we just need to define two variables. One is the environment and second is the AWS region. That's it. So we have defined the AWS region and the environment for the development. Develop and environment is development and AWS region is US West 2. The same file we need to create inside the production.tf. So let's copy the file main.tf and paste it in the production. Same copy the file variable.tf from the development and paste it in the production, right? So over here you can see we have the different configuration file for the production and the development. In the production, if you want to do some change, you can change it. So we just need to change the variable. Suppose we want to create the production in US West 1 instead of US West 2, and the environment name, this is production, right? Let's save this. Now in both case the module will be used from a common path, which is the modules. Now let's commit this code. Once the code commit will done, we will go to the machine where we are executing the Terraform. So you can see we are on the machine and we are inside the directory Terraform. Over here, let's execute git pull so that we will get the code, and you can see the Terraform project structure is being created. Let's go to this directory, Terraform project structure, put ls, and over here you can see we have the development, modules, and the production. Let's suppose we are going to create the machines first in the development. So we will go to the development and execute Terraform init. Terraform init is done. We are getting the dev instance, module instances, and dev VPC, module VPC. These are the two modules. Also, we are getting one downloading. You can see it is downloading the Terraform for AWS module VPC version 2.64.0, right? Which it is downloading from the registry.terraform.io. Then we have the initialization and the initialization plugin. Clear out the console. I have already defined my AWS access key and the secret in the environment variable, so that I don't need to define these again and again. I will execute Terraform plan directly. Now you can see Terraform plan is executing and it's successful. Total 22 resources are going to be added as a part of this execution. So let's see what are the resources. So it will create the instance. This is the AMI which is coming from the lookup, the machine type, the key name. You can see the environment is development, and as per the configuration of tags, it is getting the name instance-development. Similarly, the second resource is key. Here it is reading the key because my key is already defined inside the .ssh. Then we have the AWS security group. You can see it is getting the CIDR block range, the protocols of the egress and ingress, and the port. Then AWS internet gateway, then public internet gateway, then AWS route tables, AWS route table private, AWS route table private 3, public 1, table association. You can see the route table association, private association, and the public association. And then we are getting the AWS subnet, the private subnet 0 and private subnet 1, the private subnet 3 because we have defined the three IP ranges over there, 10.0.1 to 10.0.3. Then we are getting the public subnet 012, which is for the 1012 103, right? See 102 103. Then we are getting the AWS VPC. So if you remember, we just defined the instances and the VPC and the public key, but we are getting a lot of resources. How these resources are being created? Because these are resources are defined inside the module which we just consumed in the VPC. See, over here in the custom VPC module, we have consumed the Terraform AWS module VPC AWS, so that these all resources are being created as a part of this module. Execute Terraform apply, and we have to wait until all of this will be done. We will provide yes once it will ask, and it will start generating the resources. So you can see it is creating the resources, the AWS key pair, subnets, internet gateway, and the routing table are being created. The instance creation is in progress. So we have to wait until the complete resources will be created. And you can see all 22 resources are being created. Now we will go to the AWS. Once you will go to the AWS, we need to go to the US West 2 because we have created the resources or the development environment in US West 2. Let's go to the US West 2. Inside the US West 2, let's open the EC2 instances and the VPC. Let's go to the VPC first and see over here we are getting the 2 VPC and 10 subnets. Open the VPC and we are getting VPC development as well. This is the VPC which I just created with the Terraform, right? If you will go to the subnets, then here we are getting the subnets for the VPC development, VPC US West 2A, 2B and 2C. Same for the public and the private. Go to the route tables. We are getting the VPC development route table as well. So all the resources which we created are basically present over here. If you will go to the EC2 instances, one EC2 instance is running. The name of your EC2 instance is instance-development. I will open this. Over here we have the detail of the instances. This is the VPC ID, right, which is VPC development. It means my VPC. This is the availability zone US West 2A. You can see the security group is allow SSH development. If you want to see the inbound rule, outbound rule, you can go to the outbound rules. You can see the subnet IDs, VPC development public US West 2A, right? So all the resources which we created in the development are basically being created. Now let's go to the Terraform machine again and clear out the console. After this, we will move to the production, right? Execute the Terraform init again. You can see the initialization is same, instance, VPC, then the module which we are using. We will execute Terraform plan. This time we are creating the production in US West 1. If you want to see, let's go to the variable.tf of the production, and we are creating the production in US West 1. You can see it is going to add 22 resource. Let's execute Terraform apply, hit enter. Once it will ask provide your confirmation, hit enter, and you can see the resource creation is in progress. We have to wait until all of the resources will be created, and we are getting few errors that US West 1B parameter for the availability zone is invalid. It means US West 1B is not present. So we can do one thing, we can change the US West 1 to some another reason. So I will clear out the console, and before I will execute the Terraform destroy, so that the resources which is created in US West 1, they should be removed. So the Terraform destroy is done. Let's clear out the console and we will change the reason. So instead of the US West 1, let's take EU West 1. EU West 1 have all the regions A, B, C, But according to this, we also need to change the variable.tf of the create instance, right? So we need to change the EU West 1, mention the AMI of the EU West 1 over here. Now we will commit this. After the commit, we will go to the machine where we are executing the Terraform, get pull. Get pull is done. PWD, we are inside the production. Execute the Terraform, apply again. This time we are creating the machine in EU West 1. Provide your confirmation. Resource creation is in progress. We have to wait until all of the resources will be created. You can see the instance creation is in progress. If you are getting some ID like 400 unsupported configuration supplied, it means the AMI which you are supplying for your reason is not valid. So you need to supply the correct AMI. Otherwise, this configuration will work seamlessly. There should be no concern in this configuration. So we have created the development environment in US West 2 and production environment in EU West 1. It means Europe West 1. You can see all 22 resources are being created. Let's go to the AWS and switch to the EU West 1, which should be, I think, Ireland. Yes, EU West 1. You can see the instance is created. This instance is using the VPC production. Allow SSH production. If we will go to the VPC, we have the two VPC. Let's go to the VPC. The VPC name is VPC-production. Go to the subnets. VPC-production public. How we are getting the this name hyphen production? Earlier we was getting the hyphen development, because the same thing we have provided in the code. If you will check, then inside the VPC you can see the name is variable.environment, so that I am able to create the same resources in different regions. Now this is the way how we can work with the production environment. So we have the modules which are basically the resource definition for the AWS resources. Then as per the development and the production environment, we will change the configuration and we will execute the Terraform configuration for the development and production. And if you want to create some another environment, you can create that environment as well. Now let's go to the Terraform again and execute Terraform destroy. Same thing, you need to go with the development project and execute the Terraform destroy, so that you will kill all the resources which you created as a part of this lab. So this is the way how we can manage the production environment and what should be the project structure for the production environment. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will discuss about the build automation tool called Packer. We will see what is the Packer and how Packer will helpful and how we can use the Packer with Terraform to get more stabilized infrastructure. So let's start with. So before starting with the Packer, first I would like to tell you that Packer is a tool of the same organization. HashiCorp is the parent organization of the Packer tool. Terraform and Packer both are the tools of the HashiCorp. Now let's discuss about the Packer. So Packer is an open source tool for creating identical machine images for multiple platforms from a single source configuration. That is the basic definition of the Packer. So by this definition, we can understand few things. First, Packer is not a licensed version. Packer is a open source tool from the HashiCorp, and that will be helpful to create the machine images. It means the AMI in terms of the AWS and the Google Cloud images in terms of the Google Cloud. These images will be identical and that will consume some single source of configuration. So with a single source of configuration, we can create the multiple images with the Packer. And Packer will create the images which will be executable on the on-premise or the cloud machines. So the machine image which we have created via Packer is a single static unit that contains a pre-configuration operating system and installed software which is used to quickly create new running machine. So let's understand what is this. It means the machine image we are creating from the Packer, that is going to be a single static unit. It means a single static image that will contain the pre-configured operating system, right? Pre-configured operating system plus installed software which is used to quickly create the new running image. So what this will contain? So we are saying that Packer will contain the pre-configured image plus it will contain the configuration, right? So what is this pre-configuration image? This pre-configuration image is basically the operating system. And what is this configuration? This configuration is basically the packages which needs to be installed. So Packer will contain a image with the combination of these, right? It means once we will use the Packer, Packer will basically download the operating system which we want. It will install that operating system, and after that it will execute the configuration or the packages which user want in their application. Packer will configure those things, and then again it will create a new bundle which will be a new Packer image or new machine image. So Packer will consume a operating system, the operating system which you will define. It will do the configuration as per your defined configuration. That configuration either can be pushed by the chef, Ansible, or some shell script, right? You can install anything. Suppose we can take an example that we want, suppose we want predefined nginx installed on the CentOS 7. So this particular configuration will be the CentOS 7, and this configuration will be your nginx. So Packer will download the CentOS 7, then it will install the nginx on that particular CentOS 7, and that will create a single image which will be the next AMI or the image for your machine, which will be a ready to use image for your machine, right? So that you don't need to install the AWS basic AMI and install the nginx on that. You just need to install that Packer image which you just created over here on the machine, and machine will be ready as soon as the boot will complete, right? So this is the benefit of the Packer image allow you to launch completely provisioned and configured machines in seconds. So as I told you that Packer image is already have the OS plus all the configuration. So as soon as you will install the Packer image on your EC2 instance or the Google Cloud instance, that will be a ready to use image. So as soon as the boot will complete, you can use that image because you don't need to execute or you don't need to install any configuration at runtime on that image. That is already pre-configured. Now let's understand how Packer will build the images. So here is the Packer, which is the open source product from the HashiCorp. That Packer will basically combine the machine image plus a JSON. Here the machine image is the operating system which you want to install. Either that can be the Linux, Unix, CentOS, Fedora, or anything. JSON means the Packer template. Packer template is a JSON format where you need to define that which kind of configuration or which configuration you want to install on your machine. Once Packer will have the information of the machine images and the JSON, it will create a temporary EC2 instance in case of the AWS, or if you are executing the Packer on the Google Cloud or the Microsoft Azure, then it will create the GCP VM or the AWS Azure VM. This is the temporary instance which Packer will create and install the operating system which you have defined over here, right? Plus, this will also have a JSON which is a Packer template. So once on this particular EC2 instance, the machine image installation will be done. This will configure all the packages which you have defined inside the template. And then it will create a new machine image which is a ready to consume image for your VMs. Because that have the operating system plus all the packages which you want to install at your AMI at runtime, so that the new image which we are using, that will be a ready to consume image. You just need to install that image and start your service. Now let's discuss about the component of the Packer or the Packer terminology. So first thing is the template which we have discussed earlier. That is a configuration file which used to define that what image we want to build and what are the other configuration we want to make it on that image. Then we have the builders. Builders are responsible for creating the machines and generating image from the various platform. There are separate builder for each cloud provider. Each is on configuration. So if you are using the AWS, we have the separate builder. If you are using the Google Cloud, we have the separate builder. If you are using the DigitalOcean, Microsoft Azure, Alibaba Cloud, so each cloud have the different kind of builders. And the last component, we have the provisioners. Provisioners are basically used to install and configure the machine image after the booting, and they prepare the system for use through the example installation in necessary package. So provisioners will basically install the image on the machine which is being built by the builder and the image which is mentioned in the template, and then it will install all the configuration which is mentioned in the template and create a new ready to consume image. In our examples or in our case, we can use the Packer to build the AWS AMIs. Till now we was using the AWS image specific or the OS specific AMI, but with the help of the Packer we can create our own AMI. The next benefit of the packer is that the custom AMI will be handy AMI with pre-installed configuration. So till now we have seen that with the help of the local exec or the remote exec, we install the AMI, then we install few software on that particular AMI, right? And then we will start the application. But with the help of the packer image, we don't need to do that. What we will do, we will consume the AMI in the packer and we will list out all the packages, all the configuration which we need in our image, so that packer will generate a custom AMI which will be very handy and just ready to use after the installation on the VM. This will speed up the boot time of the machine definitely, because we don't need to execute anything on the machine at the boot time. Till now we just executed few shell script and a few installation, but in the production machines, in the production heavy applications like Cassandra or some open source directory database, some HBase application, some analytic application, they have a heavy software and that installation will take place. So what we will do, we will build these images with the help of the packer, so that we don't need to execute anything at runtime on the machine. This will helpful to create the cluster services. Definitely this is helpful to create the cluster services, because with the help of the packer we have the definite image which we can use in the service, so that all the nodes which are the part of my cluster, they can use the same image which is being created by the packer. So thank you team, that's about the application of the packer and the basic introduction of the packer. Hello team, welcome back. In last lecture we have discussed few application of the packer. Today we will see how we can install the packer on the Linux box or Unix box. So let's go to the machine where we are executing the Terraform. So here is the machine where we are executing the Terraform. Now we will go to the browser to get the packer path, and on my browser I will type download packer. You can see the very first link we are getting, www.packer.io. I will open it, and here we are getting the different distribution for the packer. For the Mac OS, for Windows, for Linux. In the Linux we have the 62-bit, 32-bit, right? ARM, AMD for the FreeBDS, open source, Solaris. As we are using the Linux, so we will go to this and we will copy this link. On my box, we'll execute wget, then this link of the packer. I'm downloading the packer 1.6.5 AMD64 zip. The zip is basically downloaded. The total size is 104 megabyte. Let's check, and the packer zip is over here. Let's unzip this packer zip. So unzip packer, put ls, and we have the packer over here, right? Now let's remove the zip. So I will type rm-rf packer underscore zip. Once the packer will install, what you need to do, you need to move a packer. So I will execute sudo mv packer, and I will move the packer in user local bin, right? Now let's execute the packer, and you can see we are getting the packer native command. If we will execute the packer -version, we will see that packer version 1.6.5 is installed on my box. And these are the available commands, in the packer: build, console, fix, inspect, validate, and version, right? So in the coming lecture we will see how we can create the configuration file for the packer and how we can create the custom AMI with the help of the packer. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And in this lab, we will see how we can create the custom AMI with the help of the packer. Till now, we was using the EC2 instances and we was using the AWS default AMIs, right? Today, we will see how we can create the custom AMI with the help of the packer and how we can use that custom AMI to provision the further instances in Terraform or AWS. So let's start with. But before I start with the custom AMI, let's try to understand the flow of packer. So packer will execute in this particular flow. First, it will have the validate, then it will have the build. After the build, it will have the save artifacts, and after the artifact, use artifacts further in Terraform. Right? So this is the build flow in the Terraform. First, once you will create the packer template, you will execute the packer validate. Packer validate will validate the template you which you created, and if there is any error in that particular template, then packer validate will throw the error that template have the errors. Once the validation will be done, you can execute the packer build. Packer build will execute the packer job, and it will do all the things which is mentioned in the template. Once the execution will be done, it will save the artifacts in the destination. We will look into it that how packer will save the artifacts. And once the artifact will be saved, here the artifact is the machine images. These machine images further used by the Terraform to create the another instances. So this is the complete build flow of the packer. Few component or the important component we have already discussed which are present in the packer. The very first is variable. After the variable we have the builder. After the builder we have the provisioner, and after the provisioner we have the post preprocessor. So these are the components of the template, right? So let's go to the machine where we have installed the packer, and let's see how we can create the packer template and how we can validate and execute the packer template. So we are on the code editor, and here we will close all the files. Inside the Terraform directory, I will create a one more folder called packer. Inside this packer, we will create a directory called scenario 1, and in the scenario 1 we will create a template file. Let's call it scenario1.json. There is no hard and fast rule, you can keep the file name anything. Inside this JSON we will define the packer template. So very first we need to define the variable, then we need to define the builder, and then we need to define the provisioner. In this example we are just going to take the variables and the builder. We are not going to take the provisioner. In the coming lectures we will see how we can use the provisioners as well. And over here you can see I'm defining a JSON template for the packer. First I'm defining the variable. Inside the variable I'm defining the AWS secret key and inside the variable I'm defining the AWS access key and the secret key. Although I didn't mention the secret key and access key over here, but once I will execute this, we need to mention the AWS access key and the secret key on the machine where we are executing this file. Then after the variable, you can see on the same or parallel node, I'm defining the builder, defining the JSON array, and inside the builder, the first element is the Amazon EBS. I'm going to define the access key and the secret key with the help of the user and the variable. You can see the user variable taking this variable from over here. Then I'm going to define the region, in which region I want to execute this builder, which is US East 2. And then over here I'm defining the source AMI filter. You can directly define the source AMI, or you can get the source AMI with the help of the source AMI filter. And over here inside the source AMI filter, I'm defining the filters to get the AMI. The default AMI I'm taking virtualization type HVM, and the name of the AMI will be Ubuntu Images, Ubuntu Xenial 16.04. The root device will be EBS and the owner will be this, right? How can you get these information? These information is available on the Google Cloud documentation. Let me show you. Here is the Google Cloud documentation for finding the Linux AMI. And if you will find for the Ubuntu server 16.04, you will get this information. The owner is this, the name is this, the value is this. And over here you will get all the information, and you can see the same information we are defining over here. Then we are taking the instance type, that which temporary instance type this packer will create. This will create the t2.micro. Then the SSH username, which is Ubuntu, and then I'm defining the AMI name which this particular packer will create. So this packer will create AMI called scenario1 packer timestamp. What I will do, I will save this and commit this file. After commit the code, we will go to the machine where we are executing the Terraform, and we will go to the directory Terraform. Here I will execute the git pull, and you can see the packer directory is being created. I will go to this directory packer, then I will go to the scenario1, put ls, and over here we have the scenario1.json. Then what we need to do before execute anything on this template, we need to define my AWS access key and the secret key. In your case, this value could not be null. You need to define your AWS access key and the secret key over here to execute this packer, right? So I will go to the insert mode and define my AWS access key and the secret key. After define my AWS access key and secret key, I will save the file, clear out the console, and I will execute a packer validate scenario1.json to validate this JSON, right? We are not getting any error. It means this JSON is good. Now to build the packer, we will execute packer build, then the file name of your template. Hit enter and it will start the building. You can see over here we are getting the logs that found image ID. It means the image ID which we have taken in our packer builder, it is being found. Then you can see it is launching the AWS instance and the name of the packer is the packer builder. If we will go to the AWS, we'll go to the EC2, go to the EC2 instances, then you can see and go to the instances, running instances. Then you can see instance called packer builder is in progress, which is a t2.micro. It means this packer, the packer we are executing, that packer has created an instance and downloaded the AMI which we have defined inside the packer on this instance. Now the instance is stopped. We have to wait until the AMI will be created. Over here we are getting the logs like waiting for the AMI become ready, right? So this is the way how packer will work. As I told you that packer will initialize a temporary EC2 instance, install the AMI, then put all the configuration on that AMI, right? And then create the new machine image. So over here it is creating the new machine image. So we have to wait until the new machine image will be created. You can see we are getting the next message that terminating the AWS instance. If we will go to the AWS, go to the instance, the state is terminated. Clean up, cleaning up the extra volumes, no volume cleanup escape, deleting the temporary security group, deleting the key pairs, finishing after 3 minutes 5 seconds. Total time took 3 minutes 5 seconds. And over here we are getting the message build finish, artifact successfully built, and this is the Amazon EWS AMI, right? The AMI is being created in the US East 2 and this is the AMI ID. This is the new AMI which Packer created after using the AMI this. So although we didn't execute it or we didn't install any new configuration on this AMI, but still a new AMI is being created. How we can verify that? Let's go to the AWS and over here you are getting the AMIs. Let's go to over here and you can see your newly created AMI is present over here. Scenario 1 Packer. Let me open it. The name of the AMI is Scenario 1 Packer, then the timestamp, and this is the ID. If you will copy this, the ID which is being printed over here, find it here, you can see this is the same AMI which is being created by the Packer. You can also identify it if you are going to launch a new EC2 instance. So let's go to create a new EC2 instance, launch EC2 instance. It will ask for the AMI. Let's go to the my AMIs. And over here you can see you are getting your custom created AMI, scenario 1 packer, the timestamp, then the AMI. The type is EBS, the virtualization HVM, and honor is this, which is your account ID, right? So this is the way how we can create the custom AMI with the help of the packer. Although we didn't execute it, we didn't install on this AMI before creating this AMI, but this is the way how we can create the custom AMI on AWS with the help of the packer. If you want to delete your custom AMI, you can simply go to the AMIs, select the AMI which you created, go to the actions and go to the deregister. Click on continue, it will delete your AMI. So that's all how we can create the custom AMI in the AWS. In the coming lecture, we will see some more use cases with the Packer and the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Google Cloud Training. And today we will see another lab on Packer. In last lab, we have seen how we can create the custom AMI with the help of the packer, but we use the variables and the builders to create that AMI. Today, we will again see how we can create the another custom AMI, but we also use the provisioner so that we can do some custom configuration on the default AMI and create a custom AMI which have the default OS plus the additional stuff which we execute with the help of the provisioners. So let's go to the code editor and create the packer template first. So in last lab, we have created this template scenario1.json. Let's create one more directory in a Packer, and I will call it scenario 2. I will copy the scenario1 JSON and paste it in the scenario 2. Then I will rename it as a scenario2.json. Right. So here we have our scenario 2 JSON. Over here we have the builders. After the builders, we will add the provisioners over here. And as we are going to add multiple provisioners, so we will keep the provisioners in a JSON array. First, we will use the file provisioner, where we will read the file from the current directory and paste the same file or put the same file at a specific location on the AMI. So we will create some file over here called hello.json or hello world. Let's keep it text file, and here we are mentioning something like hello team, this is custom AMI by a Packer. Now I will keep that particular hello world.txt file at a specific location in my custom AMI. So we will use the file provisioner over here. So you can see we are using the file provisioner, and we are reading hello world.txt from the current location, and we are putting the hello world.txt at this particular location in the custom AMI, which is home Ubuntu. After this, we will put another provisioner, and suppose this time I'm using the shell provisioner. And inside the shell provisioner, so you can see the type is shell. Then we have some inline commands, ls-al home Ubuntu. Over here we are listing out all the directories which is present inside the home Ubuntu. Then we are getting the content of the hello world.txt. And here the shell provisioner is basically ending. Let's create one more file over here and call it install nginx.sh. And here let's put some file like sudo apt get update, then execute sudo apt install nginx. Right. Now I will define another shell provisioner over here, and we will read this particular file which we have created. So you can see I'm defining another shell provisioner over here, and I'm executing the current file which is install nginx.sh. So in this particular template, we are using the variable, we are using the builders, and we are using the provisioner. So this is the complete file or the complete template of the Packer. Let's save this and commit this code. The code commit is done. We will go to the machine where we are executing the Terraform. Now we are on the machine where we are executing the Terraform. Let's go to the directory Terraform and hit git pull. Now you can see we have pulled the Packer scenario 2 and all the files which are present inside the Packer scenario 2. We will go to this directory Packer scenario, put ls over here, and you can see we have all the files hello world.txt, install.sh, and scenario2.json. Now first verify our JSON. Do we have any kind of error in my JSON or not? So we'll execute Packer validate scenario2.json. You can see we are not getting any error. Now let's execute the Packer build scenario2.json. Hit enter, and you can see it is starting the execution. It is waiting for the instance. If we will go to the AWS, we will go to the EC2, then you can see 0 instance is running. Let's open the instances, and over here you can see this instance execution is in pending, which is being built by the Packer builder. So we have to wait until this particular instance will be ready, so that Packer will install the AMI which is defined inside the template on this machine, then execute the provisioner, then create a new image from the disk of this particular node and terminate this node. So we have to wait. We will go to the machine where the Packer is executing, so that we will get the current logs. Now over here you can see first it is creating the template, then waiting for the template to be created, then it is trying to connect to the public IP, and over here you can see it is uploading the hello world.txt at a location home Ubuntu as we have defined inside our provisioners. The total size of the file is 42 byte and it is being uploaded in the Ubuntu. Then after this you can see it is executing the another provisioner and listing out all the content which is present inside the home Ubuntu. You can see bash logout, bash rc, cache profile, .ssh, and hello.txt is present inside the home Ubuntu. And after the ls, we have executed the cat on the file text. So you can see It is executing the cat on the file text and printing the file content over here. Hello team, this is custom AMI by the Packer. This is the content of my file. Now it is executing the another provisioner, install nginx.sh. First it is updating the packages, right? And then we are getting some error while it is basically installing the nginx. So I think we have provided the incorrect package manager. We should provide the apt-get, but we just provided the apt. They should be like apt get install.nginx. Then you can see try to download the nginx core, and it was asking for the confirmation. No confirmation was provided, so it aborted the nginx installation. And after that we are getting the error that a script exists with the non-zero existence. It means this custom AMI is not created. Let's go to the file again and provide like this apt-get-y install nginx. After this we will save this file and commit this code. If we will check the AWS, then you can see the instance got terminated, right? Although the AMI check, although the AMI creation got failed, but instance got terminated as soon as the AMI got failed. The code commit is done. We will go to the machine and execute git pull. You can see one change is present inside the install nginx.sh. We will execute the packer build scenario 2 JSON again. So you can see it is creating the instance. We have to wait until the instance will be created. If we will check on the AWS, you can see new instance is running. If we will go to the packer, we are getting the logs. It is basically updating the packages, and you can see the provisioner install nginx.sh is running, and right now it is updating the packages. As soon as the package update will done, it will try to install the nginx, and you can see nginx installation is in progress. We have to wait until the nginx installation will be done. The installation is done. AMI, the instance is stopped. You can see stopping the source instance, and it is creating the AMI. The AMI creation may take some time, so we have to wait. You can see the AMI is basically being created, and this is the ID of your AMI, right? And now it is terminating the instance. The instance termination is done, and this is the AMI which got created in US East 2. This AMI will have the basic OS which we included in the template, plus this will have the hello.txt, plus this will have the default nginx installed on the OS, right? So as soon as I will install this AMI in EC2 instance, I don't need to execute or install nginx again. Nginx will be directly available after the installation. So this is the way. If you want to check the AMI on the AWS, then you need to go to the AWS, go to the AMIs, and you can see your AMI is present over here. Scenario 1 packer, then the date stamp, and here is the AMI ID which is same, which is present on the terminal. See, right? So this is the way how we can create the custom AMI and how we can use the provisioners in packer. In the coming lecture, we will create the custom AMI and we will install that AMI on the EC2 instance directly with the help of the Terraform. So in coming lecture, we will see an example of packer plus Terraform together. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. Till now we have seen how we can create the custom AMI with the help of the packer. Today we will see how we can create the custom AMI with the help of the packer, as well as how we can consume that AMI with the help of the Terraform. So this lecture is going to be a combination of the Terraform plus packer. So first let's try to understand the structure we are going to follow in this lab. So in this lab we are going to create few component. First we will create the VPC. After the VPC we will create the security group. After the security group we will create the EC2 instances, and that EC2 instance will use the custom AMI. So this EC2 instance will use the custom AMI which will be created by the packer. So this part of work will be created by the Terraform, and this part of work will be created by the packer. Also in this particular stuff, this VPC will be created by the module, right? This security group will use this VPC. The EC2 instance will also be created by the module, and the custom AMI will be created by the packer. So this is a one part of resource, right, which have the VPC security group EC2 instance which will be created by the Terraform, and this is the another part of the resource custom AMI which will be created by the packer. Custom AMI further will use few components. So this custom AMI will use the Nginx default, plus this will also use some custom configuration. So this is the complete model we are going to execute in this lab. We will create the VPC and the EC2 instance, which will use the modules. We will create the security group. The EC2 instance will use the VPC and the security group. This is being created by the Terraform. We will create the custom AMI, which will use default Nginx and some custom configuration. This will use the packer. And this EC2 instance will basically use this custom AMI, right? So this is the complete execution flow. So let's go to the code editor and create the code files. So over here inside the packer, I will create one more directory called deploy custom image. So here we are going to deploy the custom image, which will be the combination of the packer and the Terraform. So if you remember, inside the Terraform project structure, we have created a project called modules. Then this module will have the create instance.tf and the vpc.tf. So what I will do, I will copy this complete module and paste it here in the deploy. So you can see we have the module, and inside the module we have the instances and we have the VPC. And from the VPC and the instances, what we will do, we will keep the VPC and we will remove the instances, right? So we have the deploy custom images. Inside the deploy custom images, we have the directory called modules, and inside the modules we have the vpc.tf and the variable.tf. If you want to go through with the vpc.tf, then we have already seen the same in the last lecture. We are using the source Terraform AWS module VPC, then name, CIDR block, availability zones, private subnet, public subnet, the default value or false. Then we have few output variables, my VPC ID, private subnet and the public subnet. So by this module we will create the VPC. Now inside the deploy custom images, we will create a new directory called custom AMI deployment, right? So outside the modules, we have created a new folder custom AMI deployment. Over here, first we will define the create instance.tf. So create a new file called create instance.tf. So in the create instance.tf, we need to define few things. We need to define the key value pair, we need to define the security group, and we need to define the definition for the EC2 instance. So let's define these definitions. So you can see we are defining few values over here, like the AWS key pair, which is public key path, which is level up underscore key, which is being defined from the public key path. Then we are defining the security group allow SSH. Over here we are taking the variable, the VPC ID I'm taking from the variable VPC ID. The name will be allow SSH, then the variable environment. Description is here, egress, ingress is defined, tags are defined. Then we are defining the AWS instance, and inside the name of my instance will be my instance. The AMI I am taking from the variable AMI ID. Similarly, instance type I am taking from the variable instance type. The subnet I am taking variable public subnets. The public subnet is the variable which you have defined inside your module. If you will go to the vpc.tf, over here you have the public subnet, right? Then we have the security group which we have defined at above side. Then we have the key which we have defined at above side. Let's create one more file called variable.tf, right? And over here we will define the variables which we need to use inside the create instance.tf. So we have created the variable.tf. We are using the public key path which we have defined over here, public key path. After the public key path, we are taking the environment, then we are taking AWS region, and we are taking instance type. If you will go to the create instance.tf, then few variables are still missing. What variable are missing? The VPC ID is missing, the AMI ID is missing, and the public subnets are missing. So let's define these variable directly over here. So before creating the AWS instance, let's do one thing. Let's include a module over here, right? So I will include the VPC module over here. The module we defined over here, right? We will add that module in the create instance.tf. So we are calling a module like develop-vpc, then the source of the module, which is modules vpc. Environment will be taken from the variable.environment, which we have defined over here, which is development. And AWS region will be called from the variable AWS region, which we have defined over here, which is US East 2, right? So we have defined the module over here, and we know very well that the VPC ID we can read from this particular module. So we'll read the VPC ID from module, like module dot, then the module name, then the variable name which we have defined over here. The output is my VPC ID. Similarly, we will read the public subnets. So we will read the public subnet like this. We will define element module development hyphen VPC dot public subnets, and we will choose the 0th public subnet. We also need to define the provider, so we will define the provider over here as well. So we are defining the provider AWS and reading the reason from the AWS reason variable, right? So we have the variable which have default value, we have the create instance.tf which is already being defined. Still we have the question that how the AMI ID will be generated, right? How we will get the AMI ID from the variable AMI ID? For that we need to do something. For that we need to add few more resources over here. So let's save the created resources, and what we will do, we will copy the scenario2.json and we will paste it here inside the custom AMI deployment, right? Now we will modify this JSON as per our need. So first let's change the name over here. If you want, you can keep the same name. I want to change it, so I'm changing the name like install custom AMI, right? Now the variable will be same. We are not going to change anything inside the variables. The Amazon builder type will be same. I'm not going to change anything in the builder. The reason is same. I'm defining everything inside the US East 2. The source AMI filter, let's take it same. The machine type is same. SSH username, no change in it. AMI name will be same, or you can change it custom packer. The provisioners, so we need to remove few provisioners, so I'm removing all two provisioners and just taking one shell provisioner over here, right? Let's execute few files in this shell provisioner. So suppose in this provisioner I want to execute the same thing, install nginx.sh. So I need to create a sh file over here, new file called install underscore nginx.sh. Please make sure you will keep the same name of the file which you are taking inside your provisioner. So in the command, what I'm doing, I'm taking all the variables and setting all the variable in the environment variable or in the path of the AMI. So the provisioner is being defined. Only the thing which is remaining is the install nginx.sh. So in the install nginx.sh, I'm going to define the apt get update, apt get install nginx, and the docker IO. So these are the two software which basically I'm installing as a part of the default installation. Let's save this. So now we have our code ready. We have the create instance.tf, we have the packer template, we have the install nginx, we have the variable.tf modules. Just one thing is remaining, that how we will insert this particular AMI ID, the AMI ID which we are creating. So for this, let's do one thing. Let's create the variable and keep the AMI ID over here and keep it blank, right? So we are taking the empty variable for the AMI ID for now. After this, we will commit this code and we will go to the machine where we was executing the Terraform. So we are inside the Terraform directory and we will execute the git pull. Git pull get all the source inside the packer deploy custom image. We'll go to this directory, put ls over here, and you can see we have the custom AMI deployment and the modules. We will go to the custom AMI deployments, put ls over here, and we have the variable.tf, install nginx.sh, install custom AMI.json, and create instance.tf. Now what I will do, I will execute packer, validate, and install custom AMI.json. Validation is done. We will build the packer. You can see the packer is initialized. It is creating the instance. If we will go to the AWS, refresh this, we are getting instance packer builder. We have to wait until this instance will be created and packer will execute all the custom configuration. So let's go to the logs of the packer and we have to wait. You can see it is creating the SSH connection with the machine and executing the provisioner. It is updating the packages. Then it will install the nginx and then it will install the docker IO. We have to wait until the nginx and the docker IO will be installed and a new image will be baked for my EC2 instance. You can see the all installation is done and it is waiting for the instance to stop. It is still waiting for the AMI to become ready. We have to wait until the AMI will be created and instance will be terminated. Now we can see the AMI is created in US East 2. Now what we'll do, we need to execute the Terraform init. You can see it is initializing the module VPC, downloading the VPC module from the registry.terraform.io. After the initialization, we will clear out the console and execute the Terraform apply. We will provide -var, then the AMI underscore ID, and we need to provide the AMI ID, which is being created by the packer. So if you don't note the ID, you need to go to the AWS, go to the AMIs, and this is the AMI we just created. So we need to copy this ID and provide it over here. Now hit enter. So this will start creating the AWS resources. Total 22 resources need to be created. Put yes, hit enter. We have to wait until all of the resources will be created. Now as soon as the resource creation is done, you need to go to the AWS, go to the EC2 instances, and we have the running instance development. Let's copy the external IP of this instance and let's log in this ssh hyphen your public IP hyphen l ubuntu hyphen I your key. Hit enter, put yes, and it is saying permission denied. Actually, I need to provide the complete path of my private key, which is like this. Hit enter, and you can see we are inside the machine which have the IP 10.0.101.239. Over here, let's clear out the console, and over here, if we will execute apt list hyphen hyphen installed, then we will get the list of the installed packages on this machine. So let's wait, what are the packages installed on this machine? So we are getting a lot of packages. Let's clear out the console and let's see if nginx is installed or not. So grep nginx, and yes, nginx is default installed on this machine. Let's check for the docker IO as well, and yes, docker is also installed on this machine. So if you remember, I don't install the nginx and the docker on this machine. So how the docker and nginx is being already installed on this machine? Because we are using the custom AMI, and on the custom AMI we have installed the docker and nginx as a part of the image. So we downloaded the Ubuntu image, then installed few software on it, and then we created the custom AMI which is being installed or executed on this EC2 instance, so that all the configuration we have done on that AMI, that is present on this machine. So we don't need to install the application at runtime. Everything will be installed by default if we are using the packer. If you want to verify, let's execute curl localhost, and you can see we are able to access the nginx. If you want to check the docker, so let's execute docker pull nginx latest. Let's see what we will get, and we are getting the permission denied because the docker sort connection is not created, but docker is installed on my machine. So this is the way how we can create the custom AMI and how we can create the instances with that custom AMI. Let's execute terraform destroy, so that we will remove all the resources which is being created as a part of this configuration. We will keep the AMI on the AWS because we will use that same AMI in the coming lectures. So this is the way how we can create the custom AMI with the help of the packer, and how we can use the same AMI with the help of the Terraform to create the AWS resources. So team, if you have any doubt, any question, you can let me know. Thank you team. Thanks for your time.